Howdy, Greens Prarie Elementary. My name's Ian, and today me and my friends are going to be talking to you guys a little bit about computer science. In today's modern society, computers are literally everywhere, from your phone to your watch to sometimes even your car. That's where computer scientists come in. In order to accomplish a task, such as performing a Google search or even just taking a picture, computers use something called an algorithm. Basically, what an algorithm is a couple of steps used to solve a problem. Computers are using algorithms all around the world today to solve their own problems. One of these algorithms is called binary search. And before we actually dive into what binary search is, we're going to go ahead and see how it can be used in some real-world situations. With that, I'm going to hand it off to Alex and Scott.
What's up, guys? My name's Scott.
My name's Alex.
Today we're going to go out and interview people and play a little game with them. We're going to try to get them to guess a number between 1 and 100. If their guess is too high, we're going to tell them to guess lower. And if their guess is too low, we're going to tell them to guess higher.
Yeah, so we want to see what steps they use to solve this problem. Our secret number is 82, so let's go see how many steps it took them.
Let's do it.
I'm thinking of a number between 1 and 100, and every time you guess, I'll tell you if you need to guess higher or lower, okay? All right, so what's your first guess?
40,
Okay, higher,
60,
higher,
70,
higher,
90,
lower,
80,
higher,
85,
lower,
83,
lower.
82.
That's it.
Okay, 1,
Higher,
2,
higher,
3,
higher,
4,
higher,
5,
higher,
6.
higher.
Am I getting there? Like, are we close here?
You're getting closer,
It's
yeah.
Okay, here. How about this? 8,
37,
Higher,
49,
higher,
65,
higher,
47,
higher,
75,
higher,
99,
lower,
86,
lower,
16.
higher.
Come on. How long are we doing this here?
You'll get there
Look, okay,
eventually.
okay.
You're on the right track.
All right.
Yeah.
20,
Higher,
21,
higher,
22,
50,
All right, so 50, you need to guess higher.
75,
Higher,
85.
lower. What was your approach to figuring out what the number was? Did you have some sort of reasoning?
Like start in the middle and then like kind of like just gradually, I don't know.
higher,
61,
higher,
63,
higher,
65.
higher.
I was just trying to kind of get an array or like a spread, you know, kind of going back and forth, and then you just narrow it down.
Higher,
83,
lower,
81,
higher.
82.
Yeah, it's 82. Awesome. So just one last question. What was your approach to figuring out the number?
Just go in the middle.
Okay, so like you go in the middle every time?
Approximately, but I'm not that good at simple math, so like it didn't quite work out all the time.
81,
Higher,
83.
lower.
Okay, let's go. Okay. 82.
That's it, dude. Good job. Woo! All right, let's look a little bit closer at the two different strategies that Logan and Rebecca did. So as you can see here, I have about 12 cards with numbers on them. These cards are sorted from the lowest number, 4, all the way to the highest number, 99. And so I'm going to employ both of these strategies and see how well they do. The first strategy we're going to do is the Logan strategy. So Alex, what number should I look for?
Why don't you find 62?
62? Okay. So what Logan did was he looked at the first number. That is not 62. And he continued to flip over cards until he found the 62. Oh, there's our 62. So that took us 10 card flips to find that 62. Now let's look at Rebecca's strategy. So what Rebecca did is she started off at the middle of the list, and she checked to see if this number is greater or lesser than the number we're searching for. So let's look again for 62. So what we're going to do is we're going to look at the middle of this list. So there's 12 cards here, these two cards are in the middle. We'll just look at this one. And so we flip that over, and it's 49. We know that 62 is greater than 49, so 62 must be in this half of the list. So let's kind of illustrate that. We'll ignore these cards for now, and we'll just look at these ones. So then what we do is we repeat the process for this list. And so we look at these middle cards. We'll just look at this one. We flip it over, and it's 60. We know that 62, the number we're searching for, is greater than 60. So we'll just look at this part of the list, and we'll just take these back. And then what we do is we look at the middle again. We see it's 81. We know that 62 is less than 81. So we'll just look at this part of the list. Take this back, and obviously there's only one card left. So we flip it over, and it's 62. As you can see, that only took 4 flips of cards to actually check and find 62 in the list, as opposed to Logan's method, which took 10 flips.
Rebecca's method, which Scott just demonstrated, is what we call binary search in computer science. So what I've done is I've actually gone ahead and coded up binary search, and we're going to see how much faster it is than Logan's method for finding a number in a sorted list. As you can see, binary search finished in 0.03 seconds, which is super fast. For the exact same task, it took Logan's method over 26 seconds. So that really just goes to show, when we're dealing with a lot of numbers, how much faster binary search can be.
Binary search can be very fast. As a challenge, think about how you might use binary search the next time you're looking for a word in a dictionary. Binary search is just one of the many algorithms that make the world go round. Thanks for joining us.